Welcome to this session on taking advantage of the new features of Windows Phone 8. My name is Antti Kuntsi. I'm a consultant at Avanade, and I'm a mentor, Windows Phone 8 developer, trainer, and also a developer and software architect. And Avanade is a joint venture between Microsoft and Accenture. And we hold about a quarter of all Microsoft certificates, so there's a fast facts about Avanade. And we have a rather busy day today ahead, or the busy hour. So I'll be covering in this session new launchers and choosers. So a quick recap on how to use them, but mainly on what's new. We'll cover what's called as app-to-app communication. What's new with isolated storage. How to interact with your phone using speech, so you can talk to your phone and your phone can talk back to you. And also cover quickly what's new with the new Windows Phone 8 emulator. So starting with launchers and choosers. So a recap from Windows Phone 7 is that you can use launchers and choosers to perform common tasks. So you get an integrated experience and consistent functionality across the device. And you're activating the built-in applications for doing things like email, or sending messages, saving contacts. Launchers are one-way operations, so you send something to be done by the user, and you're not interested really in what happens with the user. You send them into a website, or you send them to send an email. Choosers is something where you are interested in getting a response, so you want them to choose a photo, you want them to choose something for you, and you want to react based on the user's choice. So what's new with choosers and launchers in Windows Phone 8? You have a add wallet item task. It launches the new built-in wallet application, and you can add items into it. So you can add payment instruments. You can add wallet transaction items. For anything else, like deals and updating these items, then you use the wallet item.saveasync for updating the existing ones you have. Other new items are maps. You have the new maps on Windows Phone 8, so you can have the map itself as a task. You can also have directions, so you can say a map direction task with a target, and it doesn't have to be an address. It can be also a landmark, and it will navigate from wherever you are now to the destination, or you can set both destination and source addresses. You have a save appointment task, which is a launcher, interestingly. Then you have sharing tasks. You can share links, you can share status, you can share a media. This is sharing into social media services. You have the traditional launch URI async and launch file async, which are mainly used for the app-to-app activation. It's also for some built-in applications that don't have any other task associated with them. So how to use a chooser? It's a bit more involved than launchers. So we are using here a save contact chooser. So you want to save a contact into the permanent contact list of a phone. So this is a new chooser task in Windows Phone 8. So you create the part or the reference in the page scope, and then you construct it in a constructor. This is mainly to get a tombstone safe event handling, and you register a event handler for the completion event where you handle what happened with the contact. And in this sample, we have a click event on a make contact button, so it stores the first name and last name and then shows the save contact task. It, as a user experience, shows to the user how that you want to save a contact. Then the user says, OK, I save it. Then the execution comes back to your application, so you are now brought back to front, and you are now executing this completed event handler where you just see what the task result is. And these task results depend on the chooser you are using, so what kind of data you get back. You can get file references from file choosers and so on. So it's the only way you can get the information from the user of an integrated built-in application. Launchers. These are newed up on the spot when you need to launch something, so you don't have to do anything in any specific scope. Anything you execute after this is irrelevant from your point of view or what happens after this. So here we make a save appointment. We set a start time, then we set a relative end time based on the start time we just set. We set a couple of nice details there on what we want to do, reminders, busy statuses into the calendar, and then we say save appointment, show. User is given the normal built-in calendar application screen on adding a new contact, just like they would add directly from the calendar application, and then they can save it, edit it, or not save it. The only way you can see in your application if the appointment was saved is you go through the new calendar API and see what happened. Is there a new meeting available for you? You can also launch built-in applications by a URI. So here's an example on settings lock. It's the only way to start some of the built-in applications. So there is a large amount of URIs available in devwindowsphone.com. I'd recommend taking a closer look at those. So you can, when you need to have something available, like for instance, you want to provide the user with a lock screen functionality, you can't force it on the user, but you can ask them to activate, for instance, the lock screen and have you as a numeric icon in the bottom if you provide such a functionality. So you have an easy way to send the user where the user needs to be, for instance, turning on the network. Let's get a bit more involved. So talking about app-to-app communication. It's quite erroneous to refer to as app-to-app. It's a lot more than that. It's one of the things, but not the only thing. It's about interesting ways you can handle specific files or you're sent, or you can send files to others. You can also handle custom URIs to interact with other applications, or you can provide a service to other applications so that you can be called with a URI to perform a specific task. So this is about auto-launching your application. A new way of starting your application instead of user clicking on it on the start screen. So they can start it by a file or by a link in an email attachment, web browser, text messages, NFC tags. Another app can do this. So there are many ways you can start your application now. And how that looks on a phone. So user launches a file or URI, and if you don't have that application on your phone, then you're given an opportunity to go and search for it on the store. And if you have multiple applications that are capable of handling the same file, you are given a choice. This is different from Windows Phone 8 and Windows 8. On Windows 8 you have a default application, and that doesn't exist on Windows Phone 8. So on phone you always have to choose which application deals with a specific file or protocol when you are launching something that can be handled by multiple ones. So there's a bit of a tip. Do not register anything that you really can't provide any actual extra usefulness to the user, or they will uninstall your application because they are wary of looking at your application every time when they want to do something with something else. So protocol associations is the other way of getting launched and launching other applications. So you register a URI, and the schema part here, the part before the colon, is what you register in. So you want to do that I handle this, and anything after that is up to you. It's for you to specify. To do it, you register it in the app manifest. So you add an extension for your protocol. The name of the protocol is your schema. You should leave the task and the Navi URI fragment as they are shown. We'll see more in the other code. The extensions it's an XML file, so the extensions has to follow the tokens, and you can have up to 10 associations per application. There are several that are restricted: mail, map, HTTP, JavaScript, file, and so on. Those are listed also on the devwindowsphone.com. You can't override or reserve protocols that are handled by the OS or the built-in applications. They will be ignored. So when you get launched, you are given a URI to your application. You have to handle it in URI Mapper. We'll look at how to make a URI Mapper later. And this gives you the bits you show. So you have the protocol in the beginning, then you have a launch URI, which is the exact URI that was given by the application that launched you. So you have your protocol schema name, and then you have whatever was after that. File types is the other way you can get launched. So you can handle a file, and you can have up to 20 different files. You can have 3 icons. They are optional, but strongly recommended. So if you have, for instance, an email attachment, and you have an application that can handle your files, these logos are shown on the email application to have a sort of indicator to the user that, yes, you have an application that can deal with this file. Again, there are number of reserved application extensions that are reserved, so doc, JPEG, MP3, you can't register those. This is also the place where you use file associations for SD card usage. So the file content type is mandatory if you want to be able to use stuff from the SD card on the devices that support SD cards. When you get launched, you get a similar URI in your launch parameters as with protocols. This time it starts with a file type association. It has a file token in it. And again, you need to parse it in a URI mapper on what that actually means. So how to do it? You write a URI mapper, which is here as a sample. So it's a simple effectively a single function class at minimum. You get a URI as an input. Then you check what it contains. In this case, it's file association. You can also see if it starts with a /protocol. Then you parse the token out of it, in this case file token, which we define in our WMA app XAML. And then we get the shared storage access manager.get shared file name with the token we were given. So we don't get the actual file, we get a token to a file. So we use the shared storage access manager to get the name of the file we are receiving. And based on the extension of that file, then we see which of the files that we are now aware of it is, and then we can navigate to a specific page passing the file ID. So the token we receive, we can't forward the actual file, or it makes little sense. You are starting here, so try to minimize the amount of code you execute while executing a URI mapper. Deal with the minimum amount of information where you can base your decision on. And then we return a URI onto a page with the token attached to the end. And if it's a URI that didn't start with the file association or protocol, then we return the URI as it was given to us, just to be safe that no navigation goes broken. So now we have this file, but how do we get called? You open up your app XAML CS, so code behind. You go to your initialized phone application, and you add the line there. So you attach the URI mapper property to a new instance of your custom URI mapper. And now, whenever there's a URI that's coming into your application, it gets passed into your application, so you can handle it and decide where to go in your application at this point. So how to access this file? So you are passed a reference into a file, so you can't access the file where you are given. So it's not a read-write access area. It's just a temporary area where the file is stored for you until you access it. So it comes in from email, it can come from a web page, or it can come from a different application altogether. It goes into the shared storage by that application when it launches you. You get the ID and you are getting launched. Then you retrieve it from the shared storage as a copy into your local storage. And then you are free to access it. So in your application, the URI mapper mapped it, so you know that what you're dealing with a proper application or proper file. It has navigated you onto a page that is capable of dealing with that specific kind of a file. So in that on navigated to event handler, it's time to retrieve the actual file. So you can do it by checking the query string. Does it contain file token, which we attached in the URI mapper? We retrieve the file token, and then we use the shared storage access manager again to copy that file into local storage. And in this case, we are replacing, for instance, any existing files just in case. So that it's one of the ways you can handle with errors is replacing the existings. And to send a file, all you have to do is you get a file from your local storage and use launch file async, and everything is done for you on the background. It gets copied to the shared media part, and the token gets sent to the target application, and you go dormant until the other application is completed. So this is a way to send files to built-in applications like Word or Excel. So you can generate a Excel file, for instance, on the fly, and then send the user to edit that file in Excel. So to do this, you need to understand isolated storage. On Windows Phone 8, all applications have two separate parts. There's installation folder, it's read-only, and whenever you update your application, anything you have there will be destroyed and replaced with the new instances of your read-only resources. This is a place where you get your read-only reference databases, read-only resource files, any templating you provide with your application. And then you have a local folder, which is the Windows Phone 7 isolated storage. This is a part where you can read-write practically anywhere, so you can keep your data there. When the application is updated, this is the part that remains. It doesn't get destroyed, so you have persistence across upgrades on your application as well. You can create any files, any folders with few exceptions. So there are basically two directories that are restricted. Platform data. This is a directory that is created by the system for you when you use photo chooser task. So that file is visible through that directory. And then the shared directory is used for media, shell content, and transfers. So media is part where you can put background images or album cover images for the universal volume control or the lock screen media display. Shell content is where you put your tile images for the background agents and actual shells. It's the only place where you can actually put them. And shared transfer is where, when you have a background transfer service in your application, that's where you are actually transferring the data. And then when you go back to foreground applications, that's where you retrieve the transferred data. So how to access these files? 3 ways in Windows Phone 8. So there's the Windows Phone 7.1 isolated storage APIs, still there, existing, working as they were. You can use the get user store for application and then give a path. You can use the Windows 8 storage API with a URI. So ms-appdata ://local. That's mandatory to have all that until the final slash in here. It always has to start with that. And then a file or path and a file. And then the easiest way to deal with this is using those static properties available to you in the Windows Storage Application current local folder. So then you get an instance of a folder where you can then easily get a file directly. How to save data? Using those local folders, it's very easy. You get a reference. So here it's divided on 2 different lines, but you can use it on a single line if you want to, but it's for clarity here. You create a file with that local folder reference, and then you create a stream for writing into it, and you're done. Reading is the inverse operation. So again, you get a local folder reference, get a file, get a stream out of it, read it, and you're done. 3 lines of code for accessing a file. So the other way to do it is when you have read-only data, you can also use the ms-appx, which is the installation data, so you can also read that. So you can pass it a URI instead of a folder reference. and this is also a way to access data. These are quite compatible with Windows 8. There are some differences, like if you want to assign in code a image on your application into the view, then you have to use a different syntax as a URI as opposed to Windows 8. So you have to still use the Windows Phone 7 syntax and notation on how to access files and how to refer to files that are in your application. This is a sample on how to do a certain operation that is not existent in Windows Phone 8 still, so file exists. If you try to access a file that doesn't exist, it throws an exception. So there is no specific function to check explicitly if a file is there or not. I did mention external storage, so SD cards. Phones in Windows Phone 8 are allowed to have those, and you have access to them. You have read-only access. You have to have a capability defined in your application in order to use it. You have to register for the file types you want to read from the SD card. That's the only part you can actually read, so you can't go through an SD card. You can't write to an SD card. It is a way to offload data the data downloading, for instance, to your application. So if you have large quantities of custom data like map data or some other business data, you can have the user download it on their PC, store it on a memory card, and then put the memory card on the phone, and then you can read it easily with the access external storage device instance that you can get. So you call a get external storage devices async. It returns you a iterable item of storage devices, 0 or 1, basically, if you have one or you don't have an SD card on the device. When you are developing applications, it's often the case when you write stuff into a file, you can use isolated storage, for instance, to serialize your state. Quite typical. When you go dormant, you serialize your state to prepare for tombstoning. Then you have to figure out why it didn't work when you came back. A tool to help you there is this Isolated Storage Explorer tool. So you can use this both on an emulator and on a device. You can extract the whole image of your isolated storage. You can create a snapshot. You can restore the snapshot, so you can do repeat testability of your state in your application using this tool. So if you are able to create an error situation that's difficult to reproduce, create a snapshot of the isolated storage and then restore it, and when you start debugging on what goes wrong when you come back from tombstone state or when you return into your application, this is the way you can easily recreate your situation. You can verify that you write your files in a format you expect to write them, and you write them in the right places. So best practices, there is no quota on Windows Phone. You are responsible of doing the right thing. Use only the amount of space you have to. Be transparent about how much you use. If you have a way of users selecting what to store on the device, have them the opportunity to unload the data or delete the unnecessary data from your application. Be a good citizen in this case. Manage your application, so delete any temporary files you don't need. Keep track of what you have stored and how much you are using space. So it's annoying to the user when they run low. When you get to about 10% of disk space left, the user is told that you are running low on memory. And then the user has to actively go forth and destroy emails, destroy images, destroy videos, and if they find out that it was your application responsible for that, then you will get a bad review. Serialization is another best practice. Do it on the background. When you come back, deserialize on the background if possible. And don't use the UI thread, so keep your UI flowing, keep it quick, keep it responsive, and use data binding so you can achieve serialization and deserialization conveniently, and you can get the data transparency that's inherent in good applications. Then one new feature in Windows Phone 8 is speech. So using speech is a new experience. You can enable both starting your application, and you can also synthesize speech. So it can make an application a lot more intuitive. So in order to use it, you have to declare a capability. This also applies to synthesis. So when you use synthesis, you still have to define speech recognition capability for your application. And the quickest way to do it is basically those two lines there. It creates a speech synthesizer and says, I like cheese. If you want to talk into a different language, so it uses the default language of the phone. So you can query also the language from the synthesizer you get and what that is. And if it's not the one you expect, you can change into, for instance, in this case, French, and then do your speaking in there. In addition to standard text, you can also use the speech synthesis markup. So you can speed up, slow down, change the pitch, change the voices on the fly, add emphasis on words. It's a fine-grained control. You can get markers out of it, so you can synchronize your screen into the speech using SSML. So reading the SSML spec doesn't take long. It's well documented, well exampled in the devwindows.com. So you can find several good examples on how to use speech output on your application to get a good impact and good usability. The other part is speech recognition. So in Windows Phone 7, you used to be able to hit the Windows key, keep it pressed, and say, open my application. And that's it. In Windows Phone 8, you have more. So now, in addition to launching your application, you can also pass data into your application after the actual launching name of the application. So you can add a more natural way of starting your application. So to start using these, for instance, you have to figure out what you want the user to do. So if you have a game, you can say, start my game and start at the last level I completed, or start level 16. And then you can parse that in your application easily with the voice command files. And you get a easy-to-understand reference on what the user wants you to do when they start your application. These are available after your application has been run once. So you have to register a voice command file in your code. And you can update it on the fly also as you're running. And there are a couple of other things you can update easily as well. So let's take a look at how this works. So let's assume we have a fortune teller application. We want to provide a simple part where you can ask a fortune teller a certain kind of fortune. It can also tell you in voice on what the output is. So voice commands have a good discoverability. You have these examples, as you can see here. It has the did you know, here's a list of supported voice commands if your user is unfamiliar with the feature. So take advantage of these as well in your application. So use the examples on what to say to your application. So how to create such a voice command. So here's the fortune teller's voice command file. So typically it starts with a command prefix. Your application name might not be easily pronounceable, so you can make it pronounceable here with a command prefix. Then you have a example. So this was in the did you know you can say stuff, and this is the part that's used there as an example. Then you define a command. So this is your internal reference to a set of things that the user can do. You can have multiple commands. Then you have an example for that command specifically in your application. So you have also in-app helping when you're starting an application. So if the user mumbles, for instance, then they can be given a help text of what are the things to say. Then you have a listen for element. You can have several of these. So you can create a more natural way of dealing with speech. So not all people use the word open. They can also say start or show. So you can disambiguate those by listing separately. These are the words that I understand here. You can make things optional. So here the will I find is in brackets. So that's optional. The user doesn't have to say will I find. And then I have this future money in these curly brackets, which means there is a phrase list that I understand where here is something that the user wants to say, but I'm not sure what. And then I have a feedback element, which tells both in text and in speech to the user what was identified. So the user can still back out and hit cancel if they figure, oh, that's not what I said. You have a navigation target, so you can navigate to a page. Only the page name is here. And then you get passed as query string a bunch of parameters that you can then look at on what was actually parsed and what was given to you. And then we have this phrase list that's referred above. So here we understand 3 things that the user can ask. They can ask if will they find money, riches, or gold. And if they ask for something else, then our application has no idea what they mean. And this part is something you can dynamically change, for instance, in background tasks. So if you have a movie player, you can easily create a list of your movies. You can have the basic phrase there and on what to do, and then you add the phrase list up-to-date version of it in your background tasks. So you can update these on the fly. How to set up? Once in your application, when you start up or when you're running, call this with your URI. It doesn't have to be even in your application. You can also do it with the URI directly elsewhere. Then it registers your voice definition into the application. If you put a breakpoint here when you execute an application, you can see that it throws an exception if you have typos in your VCD file. When you get started, the query string comes like this. So you have a voice command, which is the command that was identified in our voice command file. Then we have the phrase list, the future money. It's given also to us in a parameter. And in this case, the user wanted to know if they will find gold. So we get a gold as a phrase that was recognized. And we also get the full phrase that the user told as it was recognized by the speech recognition engine. So apparently the user asked, fortune teller, will I find gold from the phone? When you start dealing with it in your unnavigated 2, all you have to do is check, do you have a voice command name in your query string, and where you navigated into this file as a new page. So not a forward or backward navigation, it's a new navigation item. And then you can deal separately on different parts of the phrase. So you can do a very complex behavior on this, even on a single page, let alone dealing with multiple pages in your application. Then we realized that we want to support different kinds of money in our fortune teller. So all we have to do is get our command sets and add different kinds of money that we support. Now the user can ask for different things if they can find something. So this is how you can launch your application, but that's not really good enough, because when you are using a phone and you can't really tap into it, you have to have some kind of way. You can also keep the interaction on speech, so you can use speech as an input method also while you are running. So to do that, the simplest way is called recognize UI async, and it gives you the string that the user said if it succeeded. And you get some kind of notification also on how trustworthy the results are. So this is the easiest way to deal with speech recognition. Now you can customize this quite a lot. So you can give different kinds of UI feedback elements on it. You can ask it not to tell back what was recognized. So you can just go back to your application quickly. You can set babble timeout, so how long it listens to some nonsense it doesn't recognize, how long it takes until it realizes, okay, user has shut up, now it's time to recognize what was done. And you can also adjust different kinds of grammars also to make it easier to understand. So there are different kinds of grammars. So in addition to the free text search that's the default, it uses a language, it uses the search capabilities, it uses relevance information based on overall usage of speech on the background agents. These are all, speech recognition all require network connectivity, so they all are happening on the background services in the cloud. So they all deal with quite up-to-date data on what's going on, but you can make it better if you have a limited amount of information that you are interested in. You can create a speech recognition grammar specification, and it's an XML file that you can add there. And you can define a simple or a complex version of what is recognized by your application as you are running and when you start to activate the speech input. You can also have a simple selection list there. If you want the user to choose between a couple of different options, you can get pretty much a 100% success rate by if you only give the list of words that are understood as choices and then recognize any of these. So you can make it a very, very effective, a very quick speech interaction with the user. To use them, you have to use, for instance, the phone, or you can use the emulator. So all these features that I've talked about, they work in the emulator. So the Windows Phone 8 emulator is a full Windows Phone OS cross-compiled into a Hyper-V environment. You can run it on your PC. I also know that you can run it even on certain virtual machine setups. So if you have Windows 7 big machines that you are afraid of upgrading to Windows 8, you can do, at least with some virtual machines, you can run Windows 8 on a virtual machine and still be able to run emulator in it. It is the same data as on a real phone. It comes supplied with the SDK, and you can have location, orientation, camera, etc. Things that are not that well emulated, completely missing Bluetooth, NFC. Certain sensors are not there, and realistic camera isn't there either on a real phone. So if you are doing camera lenses in your application, it's worthwhile taking a screenshot from your phone, not from the emulator. Performance-wise, it is a proper Windows OS, so the events are the same as on a real phone, but the actual timings differ. It's a different architecture, different CPU, different hardware altogether. So you can do it with a functional testing. You can do rudimentary profiling. You can find hotspots in your application that need to be identified. You can do all that with the emulator, but you can't obviously do actual performance evaluation. So if you have heavy XAML animations on your application, it can look extremely fluent on your emulator, but when you run it on a phone, the limited hardware might make it stutter, so you have to run it on and do a performance analysis and responsiveness analysis on your phone. One interesting feature is that since it is a full part, it doesn't come with the shipped test data like the Windows Phone 7. But one way of dealing with it is you can access your Microsoft account with your emulator, just like setting up a regular email on a regular phone. You get contacts, calendar, and email, so you can have a repeatable test data set or easily manageable test data set. Or if you have an Exchange server on your own, you can also use that as an email account. So you can get those. So you can get a better control with the different kinds of backend systems for development. One new feature also is a simulated dashboard. So you have network simulation, you have lock screen control. So when you develop a lock screen application, you can toggle the lock screen on and off from the dashboard. You can kill the network in the middle of download to see how your app reacts. You can also slow down the network to see how your application behaves when you are running on a really low bandwidth network connectivity. That's often been a bit of a concern when developing applications that are heavy on data downloads. They are developed typically on wireless LAN. Even when you are using a phone as a debug agent, you're still connected through wireless LAN typically, and you don't get the real-world experience when you're debugging. Using the network simulation, you can actually slow down the network on your emulator, and you can figure out how your application reacts when it's slow and laggy. A hot topic is the local host. So it's running in Hyper-V, which means it's running a full virtual machine. Local host in Windows Phone 8 emulator is the Windows Phone 8 emulator. It has the listening socket, so if you have a couple of threads in your application, you listen to a connection in one socket, you can connect to it from the other thread using a local host as a URI, as the connection string. So obviously, if you develop a web application on your IIS or IIS Express with Visual Studio, it won't work if you have a local host there defined as your target host. So how to deal with this? is you go to your IIS Express or you go to your IIS and open up your firewalls so that you can allow incoming access to your services. You define your host name as the target on your project where you're running it, and then you can start debugging also the server side fluently. So you can do the WCF connectivity. When you do stepping, it can actually step from the phone. Even if you're running it on a real phone, you can step out of your code or step next in your code from your phone project into your backend project, all connected at the same time. So it doesn't matter if you are using a phone or emulator, the connectivity stays the same in this case. And so doing this in IIS Express is one line. So you find out your project in IIS Express in the configuration file, and you find there word localhost. Take that out, and you're good to go. Okay, so let's see if I can run my quick demo here. So with any luck, I created a Tech Days 13 demo, so we can test the audio.
You clicked me.
So it speaks in a random voice. You clicked me.
You clicked me.
And it also gives a bit of indication of how we can start this application. So if my microphone is connected properly, I should be able to say something like this. Open my demo app and demonstrate speech input.
Starting speech input demo.
Good afternoon. How are you all doing? Okay, this is dependent on network, so it might not work.
We're sorry, but we can't access the network right now.
So this was using the easy-to-use speech input mechanism there. Okay, so we can also try to use the have a breakpoint here. Okay. So we can also try launching, for instance, the lock screen settings. Start my demo app and open lock screen settings.
Starting lock screen settings demo.
So now it opens my application. It knows that I can do stuff there. So I have registered, for instance, the phrase lock screen demo. And okay, still network connectivity issues here. So it uses the launch URI async to start the lock screen. Okay, I really don't have network connectivity here. Huh. Okay, so let me check my network a bit. Jossain langalla. Okay, let's try with the wired network. Bit still saying limited. Okay, so I can show you some code that's doing this. So it doesn't work at the moment. So let's look at how it's done. So what I have done here is a voice command definition, and I have here a definition for command sets. This is for US English, so you can customize these for every culture you support. And I have my command prefix because my application name TechDays13 demo isn't that easy to remember or easy to pronounce properly. I have defined 4 different listen fors where they have optional ands to make it more fluent for people to say open my application and do something, or just my application do something. I have a couple of different items I can do. So I have demo items, and then I have listed a demo item set here. I also have a British version of my application which is capable of something completely different. So I have a en-gb for UK English, and it can go to a random settings page, and then it can tell me about cheese. So when we look at how it works, all these contain a navigate without a target, so it means it navigates to my default page in my application or startup page. So in my startup page, I have my onNavigated to, so I have my voice command installation here in the constructor. But in my onNavigated to, I check my voice command, switch based on it. So if it's demos, I know I'm going to do some kind of a demo here. I can go to a settings. This was the simple recognition of text, so open text input into your application. Simple text to speech, and then an SSML. So this is a way to be more expressive about how you speak. So it would stress on how cheese is made, or what's the history of cheese, and it would find a different language and different gender for my speaker than the default one. Okay, let's see if my network is now up and running. Yes, we have internet access. My demo app demonstrate text-to-speech.
Starting text-to-speech demo. Change speech language to UK English and ask me about cheese.
So there was the text-to-speech, and it says now speech language US English here. So how to change this is you go to settings, oops, flip to the side, and you can find speech. This is independent of the other languages on your phone. And now we can switch into a UK English. My demo app, tell me about the fascinating history of cheese.
Looking for history of cheese.
So that's the default.
Cheese is an ancient food whose origin, predating recorded history, is assumed to lie in the practice of transporting milk in bladders made of ruminants' stomachs,
so it's
with
not
their
really
inherent
that
supply
natural,
of rennet.
It's not monotone anyway. So if you play around a bit on how to do stresses and speech speed, you can make it a more natural and more interesting way to talk for your app to talk back. My demo app, go to some settings.
Opening a random settings page.
So now it goes to a random settings page. So it uses the URI launcher to go to a settings page. So how did I say a lot of different things in that history of cheese? I can't possibly have all the bits there. So one thing you can do is you can put an asterisk. It's a noise marker. So you can ignore what the user is saying for a moment. So anything that contains tell me about and cheddar, Stilton, or history of cheese is a valid input for us. So this is a way you can anticipate that the user is probably going to say something here, but you don't really care what that something is. So you can ignore those bits in your voice commands. You can make it a very fluent interface to many different kinds of speakers. Right. So we've seen now roughly how to take advantage of new features. So use launchers, choosers for a good integrated experience. So you can get the application look like it's a first-class citizen in your phone. Use choosers, tombstone safely, still in Windows Phone 8. You can use file associations and protocols only if you can give something to the user and plan on what you want to give to the user. Be transparent on how much space you use on the phone. Use speech in both the directions. So it's a very powerful way of communicating with your phone and with your users through your application. And take advantage of the new emulator. It has a lot of different new features that you can really take into the development effort. And most importantly, win as one, that's my favorite slogan of the Windows Phone 8 ecosystem. So if you have any questions, thank you. Now it's time for any questions if you have any. So I think there's a micro in the back.
Yes.
Okay. If not, thank you for coming and thank you for joining.